Thank you very much, Dan, for such nice introduction, and thanks for inviting me. It's a great pleasure to present my research area to your colleagues and researchers in Geary Institute. So today I am going to concentrate on work we have done during mainly an urban environmental project, which was funded by EPA in Ireland, and the goal was to adapt and calibrate land use model MOLAND for Greater Dublin region. But before going into the MOLAND model, I will do a short introduction to GIS because I didn't know how much aware you are about GIS and what kind of capabilities GIS have. So, first of all, why we need models like MOLAND? This snapshot of newsletters shows that Dublin was recognized as worst case of urban sprawl in Europe, but by European Environmental Agency, and it was brought as an example which should be avoided by other European countries. So this shows how bad can be a situation when planning and decision making is done not based on data-driven decisions and based on other decision-making tools. That's why MOLAND is kind of a special decision support system which helps decision makers to do more evidence-based decisions to avoid such kind of scenarios. So special decision support systems are type of decision support systems which are based on spatial and geographic component, are trying to help decision makers. And they are mainly based on the geographic information systems. Geographic information system is not just a software or not just a database. It's composition of all these 5 components here: software, data, methods, people, and hardware, of course. I will not go into much details here, but I will bring a couple of examples how GIS is used, in particularly for Ireland, we have used in our research. First, GIS, which stands for Geographic Information Systems, include datasets as layers. So in this example, you can see that several layers are stored to kind of model the reality here. And the data can be in point features or polygons or lines, like for example, homes or buildings can be point features on the map, streets can be lines, district areas can be polygons. So there are 3 different main kind of datasets you store in GIS. But the best advantage of GIS is that the map is connected with dataset. So for each point, for each feature in your map, you have particular data row. You see in this example, the data table is connected with map. So for each of the data point, for each of the feature in the map, we have data, which allows us to do much more than just showing map or publishing map. We can do a lot of analysis using these databases. And GIS is very widely applied around the world in many disciplines. There are almost all, you can find GIS application in almost all disciplines nowadays. So here are some examples of mapping we have done during our research previous couple of years. This is an example of census mapping. Particularly, this shows people with third level education in 2006, and you can see rate per 1,000 people by electoral division areas. So this is a simple map. It shows just the number from census. There is no analysis here actually. So this is one of the features of GIS. You can just show descriptive information. Another example from census, and this was done by All Ireland Research Observatory. They have very good data source online, iro.ie. If you had a chance, I would recommend to take a look. So it gives you opportunity to create your own maps based on census information. So particularly in this case, we have population density by square kilometer. But you can use GIS also to do some analysis. For example, here we have calculated buildings within 1 kilometer from a bus stop. So this gives you already some indicator of accessibility. For doing such analysis, we have overlaid different datasets. Particularly, we have overlaid buildings from geodirectory datasets, and we have overlaid public transport nodes, bus stops from National Transport Authority dataset. And then, using GIS functionality, we have calculated the distance from each building to the nearest bus stop. And then we have summarized this information based on electoral division level. And this is what shows this map. Another example from IRO, this is the driving duration to emergency hospitals. Again, shows accessibility to hospitals. Now you can see which parts of Ireland are far. They are, in this legend, you can see 90 minutes is the blue one, the dark blue. Oh, sorry, I don't know what I have pressed here. Okay. So the dark blue is the 90 minutes interval. So you see there are some parts of Ireland which are pretty far from the nearest emergency hospital. Or this map shows the driving duration to secondary schools in Dublin County particularly. You can do density analysis. For example, in this slide you see construction jobs density calculated by Edgar Morgenroth in 2008. And then we have calculated similar indicator, but based on already number of organizations in construction sector in 2011. So you can compare where are the jobs concentrated and where the organizations are concentrated. And you can do also cluster analysis in GIS, showing where are the hotspots of particular sector. In this example, we have wholesale and retail trade and accommodation and food services organizations. And in both cases, you can see that Dublin is kind of major center for these sectors. Additionally, there are other big cities, but you can find also some surprising results. For example, Cork City, which is second largest city in Ireland, has not very good representation of accommodation and food services actually. And blue areas are actually so-called cold areas where there is not enough representation of particular companies. And we have also used GIS to calculate comprehensive opportunities in Ireland. This comprehensive opportunity mapping was based on calculation of 32 indicators. So they were calculated, weighted, and combined to show the overall opportunity in Ireland. This includes opportunity to education, opportunity to health system, opportunity to transport nodes, overall life quality or deprivation index. So there are a lot of indicators that are included in this map. This is just, yes?
Just a question. When you do these graphs in Ireland, is it usually using a proprietary software like ArcGIS or more open source like graphs?
In our case, we have used ArcGIS. Like UCD provide ArcGIS license, so we don't have issue with it. But in our School of Geography, we also have GRASS and Quantum GIS installed in our laboratory. So there are some researchers and students who prefer open source. Yeah.
Do you see any difference in popularity?
I would say probably the ArcGIS package is more user-friendly and functionality is easier probably to do something than in open source. But from other viewpoint, if you don't have enough funding to buy license for ArcGIS, you may do your work on open source because there are very good packages now which have a lot of even better functionality in some instances than ArcGIS. So it depends. Where are you working? What is your research topic? Okay, so now for MOLAND. MOLAND actually stands for Monitoring Urban Land Cover Dynamics. The model was developed as a part of initiative of European Council Joint Research Center, and it was kind of response to the challenge of providing means for accessing and analyzing urban and regional development trends across European states. So MOLAND model, the goal of MOLAND model is to assess, monitor, and model past, present, and future urban and regional development from viewpoint of sustainable development. To realize how popular it is, these are the study areas mainly in Europe where MOLAND was applied, and one of the biggest study areas is in Ireland and also in Northern Ireland. You can see there is some application of MOLAND model there. So there are more than over 20 regions are using MOLAND actually now. And this is our study region we have calibrated MOLAND for. So it includes Dublin County and surrounding 5 counties. The reason including Louth County was the perspective in future to join it with Northern Ireland model and see this cross-border development, how it is going. So MOLAND model works in three coupled spatial scales. The first, global level, we have figures of population and jobs entered as total, like population projections for whole region, job projections divided in three main sectors for whole region. In the regional level, these numbers are already allocated in county level, based on interregional migration of activities and residents based on relative attractiveness of the counties. And finally, in the local level, the detailed allocation of economic activities and people is modeled by cellular automata. To make it more clear, in this slide, I will present how one step of simulation works in MOLAND. So one step of simulation is equal to 1 year in MOLAND model. In this case, for example, we have this particular land use of this part of Dublin, and after 1 year, we are getting simulated land use map. But to do this, MOLAND runs through macro model, which includes these global and regional levels indicated in previous slides. So you see population and projection numbers and numbers by counties. And then in micro model level, it runs several automata model. So several automata uses different neighborhood rules. Particularly here, I brought a couple of examples just to clarify how it works. This graph shows the influence of residential area on commercial areas. So in this point, it seems that this is the distance in meters. So it seems if it is close, if residential area is close, it's good for commercial area, and it is declining. And another example here, which has negative effect, is influence of industrial areas of residential areas, on residential areas. And it's logically, people don't like to be very close to factories and measure industrial areas. That's why it's kind of big negative impact. But then people don't like to be very far also from their workspace. So there is some increasing influence here also. And we have similar rules defined between all other land use classes. Yeah.
So what's the resolution between these and
The land use maps we have used in MOLAND are based on 200 meter resolution grid. So here we have 200 meter resolution grid. But other layers which I'm going now to present, we are using other layers from GIS like street network, railway, accessibility maps. So each of them, it depends. Raster maps are mainly 200 meter resolution. But we have also vector maps like streets, boundaries, and other maps.
So the resolution of the several automata will vary depending whether you have raster or vector?
Several automata works on raster level. So it's cell, it works on cell level. That's why rasters are the base of several automata. But you can overlay raster with other data sets from GIS, like vector maps. Resolution can be different. Like we have used 200 meter resolution, which was kind of the best in our case, but it can be different. In other regions, people use 500 meter or 100 meter, depending what is the scale of the region, because it can be very slow if you are using very detailed cells. So in addition to neighborhood rules, as I told, we are using another data sets which are overlaying on these and which are helping the model to find out where the next stage of development will occur. Particularly, we are using transport zones, accessibility, suitability, and zoning maps. Just to explain, for example, zoning map is more restrictions on development by decision makers, like planning restrictions, where you cannot get permission to construct something in Phoenix Park, for example. There are some zoning restrictions. Yeah? Suitability is more physical, like where it's more suitable to construct something based on soil, slope, or elevation, or a lot of other physical characteristics. Accessibility shows the distance to major roads, motorways, and transport nodes are included to show the travel between different transport zones, particularly based on POWCAR datasets from Census. And this is how it looks MOLAND when it is running. This is actually cellular automata running based on all this information. And you can see land use types here, 23 land use types. we have in our model. In particular, these rapid growing areas are residential areas. And here you can see how the year is changing. So this model runs from 2000 to 2025, I think. Yeah, and you can see how model grows.
So it's based on past development and predicting
Actually, using past development, we are calibrating the model and then running it for future. So we have used data sets from 1990, 2000, and 2006 to calibrate the model and validate it. And then we run it from 2006 to future. The reason we have used 2006 was we have land use maps of Ireland for 2006 from current data sets. Unfortunately, there are no updated maps by now. And also census was in 2006, the previous one. So all the data was based on 2006.
The rules for the similar data are fixed from beginning to the simulation?
Depending on the scenarios, you can change. But the neighborhood rules are the same. Neighborhood rules are not changeable. Unless you want to run it, like you can run the model till particular year, change the rules, and then run it. But you can change other parameters there, like zoning, for example, transport nodes, which are more practical. For example, you have a scenario where you think that I'm going to construct something in this year. What influence this will have on my development? I will show you the examples how we have used such modification actually in the model. So now on, I will show you some practical examples we have done using MOLAND model. And the first one was a study we have done with Dublin regional authorities for wastewater management. So the Dublin regional authorities provided us their map of wastewater treatment capacity in Greater Dublin region. So you see, it was in 2009 when they have provided us. So this shows how it looked in 2009. And then they have some plans to upgrade their treatment plants in 2020. So by color actually here, you see the capacity, how much it will increase or decrease or something. Yeah? So you can see that most of the areas are increasing in capacity, which is logical. If you think population is mainly increasing in this area, so capacity should increase. Yeah? So the question was that if this particular plan is good, if it is enough to increase, or if it is necessary to increase so much, maybe there is no need. So they asked us to run MOLAND model for 3 different population scenarios. So they gave us this medium growth scenario, which was based on CSO population projection in the next 20 years. And then they have asked to run also 2 other scenarios, which is one like 15% less than medium scenario and one 15% more than medium scenario, and see how it will influence on development and particularly on their plans. And this is the resulting maps we have got. This is just showing the development actually. This is not land use map, this is just showing the development. So green areas are areas which were existing already in 2006. Blue areas are areas which are developed during this 20 years of simulation. So you can see in these 3 different scenarios, we have 3 different kind of development, and most of development, of course, occur in high growth scenario. Yeah? Then we overlaid these land use maps with catchment boundary areas. So here you can see 2006 land use map. These areas, these red areas are residential areas, and this red boundary here is the catchment boundary. So then we have overlaid this with our simulation map. This is already according to scenario 1, how land use map will look in 2026. And we see that most of the development area is inside of the catchment area, which is good. Then we have overlaid with the second scenario. Already we see there is some problem. Some areas are developing outside of the catchment plan area. And finally, the highest growth scenario has major problem here because we have pretty dense residential area developed outside of the region boundaries. And this is comparison just for residential areas, how it will look.
Is the same resolution for each of the units?
For each of what, sorry?
And each of the simulation drawings has the same resolution?
Yes, 200 meter is standard, it's fixed. We don't change it, yeah. So this is again from same simulation, another region in Donabate catchment area in Fingal, so 2006. Then we have 2026 low growth scenario, medium growth scenario, and high growth scenario. And again, in high growth scenario, we have area which is outside of catchment boundaries. But there are not all, there are other problems also. This is not just being inside of boundary or outside of boundary. So in the next, this is comparison of these three boundaries. And here we have also calculated how much residential area was increased in these particular catchment areas and how much they are planning to increase the catchment capacity. For example, in Donabate, you see this is the residential area, in blue it is in 2006. So residential area in Donabate catchment actually is going to increase about 4 times. And when we are comparing with catchment plant, we see that in Donabate they are going to increase more than 6 times the capacity plant. Yeah? Which may be fine, maybe they are doing more than they need. But the more problematic is Wicklow catchment area. We see that they have about 3 times increase in 2026 in residential areas, but they are not going to upgrade their capacity in Wicklow. So this is kind of raising some questions for them if this is necessary or not. Yeah. P is person equivalent. This is kind of a unit how they calculate the capacity of wastewater treatment. But person equivalent is not the same as one person. They have quite complicated formula how they are calculating this person equivalent. So it's a little bit strange unit, but this is what they gave us. So another example is Metro North scenario. So this was done before all this collapse and this whole Transport 21 initiative was rejected because of this financial crisis. But this study was done before the decision was made. Actually, we know according to Transport 21, the plan was to provide 7 light rail and 2 metro infrastructures by 2016. But also Department of Transport published a report in 2010 when they have indicated that it is expected that as a result of current policies, congestion and transport emissions are likely to increase and that economic competitiveness and quality of life may decline. So even though they are going to improve network, but it is estimated that quality of life may decline. And our research was pointed just particularly on transport, on Metro North to see what is the benefit to have Metro North. Is there any influence of Metro North and necessity? So MOLAND model was used to simulate 2 scenarios, one with development of Metro North and one without development of Metro North, from 2006 to 2026. So business as usual scenario was just continuation of current patterns without any development, which is now actually happening. We are not going to see major development there at least in next years. Yeah? But scenario 2 was more optimistic that Metro North will be actually developed by 2016. And let's see what our indicators will show. So this map shows how Metro North will actually pass. So we see from the Dublin city center it goes north, and these are transport zones used in a MOLAND model actually numbered. So there are several transport nodes which are transport sectors, zones which are actually intersected by metro. And after we did MOLAND simulation, like you have seen in previous example, we have calculated several indicators, and these are some of the main indicators. So it shows the total numbers of trips in whole Greater Dublin region by private transport will be about 0.5% less, and by public transport it will be about 2% more if Metro North is working. But just remind you that Metro North is not passing through whole Greater Dublin region, it's passing just part of it. Yeah? So then we have calculated indicator just for this part where it is intersecting, and it shows already more significant results. So it will be 4% less by private transport and about 20% more trips by public transport. So this shows that actually Metro North would provide modal shift. It would have effect on modal shift, increasing public transport usage and decreasing private transport usage. Another example of MOLAND model application was the study we have done recently with collaboration again with Dublin regional authorities for regional planning. First, I will introduce you some of the simplest scenarios in regional planning, kind of dispersed development versus compact city. So the next slide will show you obvious difference. So this is the dispersed development where there are no restrictions, people developing their houses without any much restriction. And compact development scenario is restricting development in metropolitan area of Dublin city. So this is kind of extreme, two extreme cases. We are not going to, this was just to show how these extremes will look. But more realistically, Dublin regional authorities asked us to run 4 different scenarios for updating Dublin regional planning guideline, which was done recently. So there were 4 scenarios. Each of, I will show you in the next slides. So first one was called continued trend. So it was business as usual scenario actually. We have continuation of the current dispersed settlement patterns. You see the suitability map. It shows how much the area is suitable, and mostly you see they are suitable except Wicklow mountains and others. It was decided not to include any special green belt or any other zoning restrictions to show the current trends of development. So only the red areas are restricted for development by law, and other areas can be used. And finally, it was just a couple of transport network updates introduced in 2012 and 2020. And this shows how, you see the year is changing. This shows how this business as usual scenario is running at MOLAND. So again, it was done from 2006 to 2026. The next one was finger expansion scenario. This was kind of to see the effect of firm policy of consolidation area explored. Development is strongly directed towards expanding metropolitan footprint. So now metropolitan footprint is kind of encouraged to have development there. And there was strict green belts to discourage excessive development in rural areas and link protected areas. So this red polygons are showing restricted areas, which are actually introduced to join green areas, like you see Phoenix Park is joined with rural areas and other natural areas here, and to prevent joining of other urban areas here. And again, transport update. All Transport 21 railways and LUAs delivered in 2016. This was very optimistic. And this shows how, in case of these scenarios, development will be. So the name finger expansion, you see they are kind of finger. This comes from this development pattern. The third was consolidation of key towns and the city. Growth was focused within existing metropolitan footprint, but also in some key towns in the hinterland. So you can see these key towns also encouraged to have some development. Zoning was also introduced as a strict zoning, even more strict than in previous example. And transport network updates. And this is how this case will develop. The zoning shows, this is the boundaries of our model, yeah? So the zoning shows till here, yeah. And similarly, it runs till here. Yeah. So all this zoning, suitability, all maps are covering just our region, this Greater Dublin region. And finally, the fourth scenario was managed dispersal scenario, which was kind of more realistic and which was actually used in regional planning guidelines, which were published recently. So this was development is focused again within metropolitan footprint and other development centers. green belts are introduced to prevent merging of towns. And transport network updates. You see there were different kind of updates there. And these were scenarios provided by the Dublin regional authorities. These are not our own scenarios. Actually, they were thinking that these are the possibilities, which one we should consider like the best scenario for Dublin. And this is how this scenario looks when the model runs. Okay, so side by side you can see there's obvious difference, like the business as usual. If we don't change anything, we continue like it was, this will happen. And then we have very different scenarios. And this is just showing the difference in development. So again, this is comparing business as usual scenario, in this case with scenario 2. So the blue are scenario 2 development and reds are in business as usual, which means the reds are not existing in scenario 2 actually. And similarly here, business as usual compared with scenario 3 and there with scenario 4. So you can see that it can be very different depending what we decide now, yeah? After 20 years, the development patterns will be very different. And we have calculated also some indicators to show by numbers what in numbers it will look. For example, this shows change in land use. And we see that mostly development occurs in Dublin and mostly green area loss also in Dublin. And this shows encroachment of development within 1 kilometer of protected areas. So for this case, for example, scenario 3.1, it was kind of sub-scenarios there. Scenario 3.1 is the best, like it's not too much encroachment, while the business as usual scenario has the most encroachment. This shows percentage of urban areas within 1 kilometer of transport nodes. Again, when you compare with 2006, the percentage is low in all other scenarios. In 2026, less urban areas will be close to transport nodes. But at least in scenario 2, we have higher numbers. So in that case, from that sense, this scenario is better. This shows mean distance between residential and green urban areas, like areas to parks or sport pitches. And for each county, you can see different. And sometimes it can be very big. Like here, we see scenario 2.1 compared with other scenarios. It can be about 800 or even 1,000 meter difference, mean difference, which is essential actually. And this is population distribution between metropolitan area and the hinterland. So, as a conclusion, MOLAND is a very powerful tool to provide, to assess policy, planning policy, to quantify the environmental impact of different land use policies, to provide comparison, discussion and visualization means for decision makers, and to analyze transport impacts and to explore a range of what-if scenarios. But most important to indicate here that this is not kind of prediction of future. This is kind of simulation of one of the possibilities in future. So the important thing here is to generate the discussions that you see, if we do this, it may happen like this. If we do this, it may happen like this. And this is amazing when you are showing these results to decision makers and seeing the discussion between them, because each of them have their own perspective, have their own specialization, and they are, like you have seen, one indicator is good for one scenario, another indicator is good, another scenario. And this is raising a lot of questions and discussions, which is leading to better decisions. So this is the overall goal of models like MOLAND. I think I will finish on this, and just to let you know also that School of Geography have this free GIS clinic opened recently, which provides some research and consulting for our researchers in UCD. So if you have any GIS related questions, you can make an appointment and come over. And now, thank you. If you have any questions, I will be happy to